white phosphorus. And as if that wasn't bad enough, we've also got liquid oxygen.
Why, we know that stuff is so explosive they use it to power the space shuttle. It would blow the lid off this place. Where did you get hold of that?
Well, from our kind sponsors, from the good people at Sigma Aldrich for all your laboratory and chemistry requirements, all at low, low Sigma prices. Ding!
That was nice of them, wasn't it?
It was.
Oh my goodness, look at that. That's the biggest one we've had lately. That is one massive light bulb.
That's a new one.
Those don't come from B&Q, mate.
Actually, then we've got it from B&Q, 3 for a twin. Right, what I thought we'd do this time round is we make our own liquid oxygen. We're going to make liquid oxygen right in front of you. And it's a really elegant experiment. We're going to make liquid oxygen right here in the lab on the dome stage. Now, what we're doing is this. We're blowing oxygen gas through nitrogen gas through this copper coil.
You should notice I'm standing over here, because this is a dangerous bit.
Yeah. And the thing is that oxygen boils at minus 180. Oh, sorry about that. Yeah, sorry, Dave. And nitrogen boils at minus 196. If you blow oxygen through nitrogen, it will turn into a liquid. All right, we there, Dave?
Coming up.
Good, okay. Right, okay, you just put the dangerous liquid oxygen. Oh, we've got a nice flow of liquid oxygen, okay. Now, what I've got is this really handy little test tube here, which is double skinned, so we can see it being formed right in front of our very eyes. Now, I'm going to splash into here a little bit, and once the test tube warms up a little bit, you can see it splashing away, and if Reese comes in a little bit closer, not too close, Reese, if he comes in a tiny bit closer, he can see that against my lab coat, I hope you can see that the oxygen is blue. Can you see that faint blue colour? Well, it is kind of blue, just a little bit. Okay, that's liquid oxygen being formed right in front of your very eyes. Now, don't underestimate how dangerous it really is. If this got on my lab coat and it got set on fire, don't even bother going for the fire extinguisher. You can't put it out because the oxygen's already there. Fire extinguishers work by covering up the fuel from the oxidants. So, we're just boiling it away because we need it for our next experiment. So this is an innocent little gas which has turned into a non-innocent liquid, and give it a few more blasts there, Dave, and very shortly we'll have enough for our experiment. And you won't see this anywhere else because no one else is too stupid enough to do it. Well, they're not. You can do it next time, Dave. Right, I think we're there nearly. And what I'm going to do is just transfer this across, and I'm going to have a few little problems in a minute because I've got to get two really, really needful elements into this receptacle. Now I'm going to put the oxygen in first.
There goes the liquid oxygen.
As far as the oxygen is concerned, this big glass vessel is 200 degrees above its boiling point. So what we're going to have to do is just let it boil off. Because the only thing worse than cooking white phosphorus in gaseous oxygen is cooking it in liquid oxygen. And I'd pay money to see that. Now, as you can see,
this is going to be a quiz later.
yeah, pay attention to that. As you can see, the oxygen is boiling away. That's what this gas coming out here is, because gases occupy much more space than the liquids that gave rise to them. And this is going to take as long as it takes, because of all these experiments, this is the one that really is quite high hazard. Isn't it, Don?
It's a very high hazard indeed. If that light bulb blows, there's a lot of glass to blow over.
It does. Now, because white phosphorus is absolutely lethal, 100 milligrams is enough to kill an adult. 100 milligrams is 0.1 grams, so I'm going to put some gloves on. Okay? Now, the next problem I've got is I've got to get this white phosphorus from this receptacle into that crucible there, and it spontaneously combusts in air. Oh, we've got some big pieces here. And so what I'm going to do is have to be really quick about it. This is white phosphorus. It's actually stored in water.
How big's that piece? About a gram?
Yes.
How many people could that kill?
Well, it could kill about 1,000 people if they ingested it. 1,000 people. So I'm going to have to be very, very careful. And I'm just going to pull this right out and put the phosphorus in, like so, and put it right back in, like so. And then we'll do a final check, get rid of all the phosphorus in the liquid oxygen, and make sure that we're all we should be. Right, oxygen's gone, phosphorus is in, doctors need to have a couple of wires to get pushed in the right direction. We'll have the house lights down when it goes, so I'm just going to touch it with a couple of rods, off it goes, and those fumes are phosphorus pentoxide, P2O5, and you can see the beautiful luminescence from phosphorus. And as it develops, you can see the tendrils forming. This is why it's also called the phosphorus jellyfish. Isn't that beautiful, Doc?
Yeah, that's beautiful. I mean, You call it a phosphorus jellyfish. It doesn't look like a huge ladybug to me.
It does look like a huge bug. Doesn't it have those tendrils are forming?
Oh, can we see over here, Risa? Look at this.
Well, isn't that jellyfish like?
Oh, I guess you're right,
It's like
yeah.
a Portuguese man of war.
Fantastic.
And it's going to burn as long as the phosphorus stays burning in the liquid in the gaseous oxygen.
Isn't that a beautiful thing to see? That's the phosphorus sun.
Oh, isn't that cute? Oh, God.
Oh, I think it's beginning to fade a little now, Hal.